Hey students, this is Mr. Bornheimer, and I'm going to briefly talk through some significant digits. Okay, significant digits, okay, or you can call them sig figs, okay, some people call them sig digs. All right, you can really, either one is fine, significant figures, significant digits. Basically, it's a way for us as scientists to really look at precision of a measurement, precision of a device, okay, and when we are measuring or when we're taking measurements, it's important to have a standard so that we can really compare precision. Now, at our level, at the high school level, our devices aren't all that precise most of the time, and many of the measurements we take and the calculations we do are already given to us. So in many ways, this is just practice for greater science. Maybe at the high school, maybe at like an AP level, maybe at the college level, or at the career level. But it's something that you're expected to know going into college. So it's something that we like to teach. We don't spend an extensive amount of time on it. And if it's something you're confused by, that's pretty normal. So it's okay. Okay, so here we go. Let's take a look at a couple of rules. First of all, significant figures, significant digits, they're telling us what numbers we should consider significant in a number. All right, let's take a look at a couple of examples here. Okay, let's go ahead and look at the numbers 0.003, 3.00, 330, and 303. Okay, now there's a lot of varieties of numbers here, obviously all dealing with threes and zeros. And I'm going to go through and just tell you which ones here are significant. Okay, so we're going to grab the highlighter and pick a color. Okay, numbers that would be significant are any non-zero number. So, oh, didn't want to do that. Here, let's do. Okay. So 3 would be significant. Okay, this 3 is a non-zero number. Okay, so it's also significant. And so let's just go ahead and underline these. Okay, so this 3 is significant, this 3 is significant, this 3 is significant, this 3, okay, this 3, and this 3. So any non-zero number is significant. Okay, then it also comes down to numbers that are, or zeros, and zeros, there are about 5 different rules we have to abide by. 4, which tell us that the zero is significant, and then there's really 1, which deals with spacing zeros, and we'll talk about what that means here in just a moment, that rules certain significant digits as not significant, or certain zeros as not significant. So let's take a look here. First of all, if you have a 0 that's caught between 2 significant digits or non-zero numbers, it is significant. I like to call these sandwiches. Okay, so sandwiches. This 0 here would be a sandwich. So we're going to go ahead and underline it as being significant. Now, the rest of these aren't necessarily significant, or sandwiches, excuse me. So let's go ahead and move on. If you have zeros that come after a decimal point and are final zeros, they are significant. So zeros that are final zeros, they have to be at the very end of a number and they have to be 0. So when we look here, you might say, well, Mr. Bornheimer, these 2 zeros come after the decimal point. However, they are not at the end of the number. They are not final zeros, therefore they are not significant. However, these numbers come after the decimal point and they are final zeros, therefore they are significant. So these 2 are significant. Now, this 0 comes after at the end, it's a final 0, but it's not after the decimal point, so it's not significant. So non-zero numbers, sandwiches, final zeros after a decimal point are also significant. So this one, and this one. Okay, so these are all significant. Non-zero numbers, sandwiches, final zeros after a decimal point. Then you have the ones that are not, and these are considered mostly spacers. Okay, for instance, this 0 right here is not significant. Okay, and you would say, well, it's the difference between 3 and 30 by putting that 0 there, and yes, it's called a spacing 0, which means that it moves the significant digits out to where they need to be, but it itself is not significant. Okay, these zeros here are also significant, or excuse me, not significant. They are not significant because, again, they're moving the significant figure down, but they themselves are not. The way I remember it is if the 0 is getting between me and the decimal, then it must not be important or significant. However, if it's not between me and the decimal, okay, then it may be important. So like for instance, this 0 is not really in the way because this 3 here is right next to the decimal. This, however, this 0 is in the way. It's between this 3 and the decimal. It's probably not significant. There's no 0 here that we have to worry about. This 3 is next to the decimal. It's not vying for space, trying to get to the decimal. These zeros are between the 3 and the decimal, though. They're spacing zeros. They're in the way. They're not significant. Okay? Now, you might be wondering, why all the rules? Why is this so important? And the reason is, okay, is that when we take a measurement, it tells us something about how much we can actually measure. Okay, so you could take something like, oh, I don't know, 7 meters, and you could try to divide it by 3 centimeters. Okay, or 3, let's just say, even say 3 meters. Okay, so if you were to even take a calculator, take 7 and divide it by 3. Okay, 7 divided by 3. That gives you a number that is 2.33333 repeating. Okay, and you might say, well, that makes sense. Mathematically, that's perfectly fine, and that's true. But let's say that you were making these measurements with a meter stick. Okay, and if you've ever seen a meter stick, you know that meter sticks, okay, have centimeter marks. Okay, and then they also have millimeter marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are millimeters, and there's 10 spaces there. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and there are more spaces. So these are centimeters, so we call this 1, 2, 3 centimeters. These are millimeters. All right, and here. If I was to write this in terms of meters, okay, as I want, and that necessarily wouldn't work out. Let's just say that this was in terms of meters. That means that I have 2 meters, okay? I have 3 decameters. I have, or decimeters, excuse me. I have 3 decimeters, 3 centimeters, 3 millimeters, okay? And then 3 tenths of a millimeter, and then 3 hundredths of a millimeter. Well, the problem here is I can't measure this precise with this meter stick. Okay, the meter stick only goes to centimeters, millimeters, half a millimeter. So the best I could do would actually be 2.3. Okay, so this is the meters, this is centimeters, this is millimeters. This would be about half a millimeter. So really, okay, this 3 right here would actually not necessarily work so well. We'd actually have to say that that would actually have to be like a 5 because it really can only do about half a millimeter is the best we could do. So really, this is the best measurement we can do with a meter stick. Okay, that's as far past the decimal as I can go. So if I were to do the math on a calculator and get this answer and put all of these numbers past the decimal point, well, that wouldn't be okay because in theory, if I was measuring with a meter stick, my device is not as accurate as 5 decimal places. It's only accurate to 3 decimal places. Now, I'm stating all of this to really get at this point, that we use significant figures because our devices, our measurements, are taken with devices that have a certain limitation in their precision. So when we work with significant digits, what we're doing is we're practicing writing numbers to a certain precision. And that practice is what helps us make better measurements. And measurements are important because a scientist truly isn't a scientist until he can take a measurement and prove his findings with that measurement. And that measurement has to be reliable, and that measurement has to be accepted. And in order to do that, you have to have numbers that reflect accurately what you've done in a lab. So that's why we use significant figures. Okay, so just a quick overview. We'll go ahead and do a quick review here. Okay. I'm going to put 5 numbers on the screen, and then I'm going to take a moment and just be quiet, and I want you to try to see if you can guess how many significant figures each number has. Okay, so let's just go ahead and I'm going to pick a darker color here. Here we go. All right, so here we go. 650, 7,000, 0.04, 5.0, 6.030. Take a moment with these 5 numbers and see how many significant figures you think they have. Just take a moment. I'll count to 10. All right, here we go. 650 has 2 significant figures. 7,000 has 1 significant figure. 0.04 has 1 significant figure. 5.0 has 2 significant figures. And 6.030 has 4 significant figures. These are both significant. This is not because it's a spacing 0. These are all spacing zeros, therefore they are not significant. These are spacing zeros, therefore they are not significant. However, this is a final 0 here on this 5.0 after a decimal point. It is significant, so we count it as a sig fig. This is a sandwich, this 0 here, it's significant, and then we also have a final 0 after the decimal point, so therefore that 0 also is significant. So here is just a quick rundown on significant figures. If you have any questions, please let me know. Otherwise, I hope you have a great night. See you tomorrow.